Picture this. You're standing here with two objects in your hands that couldn't be more different from each other. In one hand, you're gripping a solid baseball, its weight familiar and reassuring. In the other hand, you're trying to grasp something that seems impossible to hold. A cloud, ethereal and elusive. While this might sound like a whimsical thought experiment, our magnificent solar system has accomplished something remarkably similar on a cosmic scale. It has crafted worlds that are as different from each other as that baseball is from that cloud. Some planets standing firm like cosmic fortresses of rock and metal, while others float through space as enormous balls of swirling gases. Our cosmic neighborhood has truly outdone itself in creating these two distinct families of worlds, each with its own incredible characteristics and mysteries waiting to be unraveled. Today, we're embarking on an extraordinary journey through space to understand this remarkable tale of planetary diversity. We'll explore how our solar system managed to create such drastically different types of planets, all from the same cosmic ingredients. In the fascinating exploration ahead, we'll uncover several mind-bending revelations about our cosmic backyard. You'll discover the fascinating reason why some planets developed into rocky strongholds, while others evolved into massive spheres of gas. We'll also reveal a surprising and profound connection between our own planet Earth and the mighty Jupiter, a relationship that helped shape our very existence. Perhaps most intriguingly, we'll delve into a compelling mystery surrounding Mars, one that could revolutionize our understanding of how planets evolve and develop over billions of years. This journey we're about to undertake isn't just another space story. It's a tale that challenges our understanding of our cosmic home and our place within it. Before we blast off into this astronomical adventure, I invite you to become part of our growing community of space enthusiasts and cosmic explorers. By hitting that subscribe button, you're joining a passionate group of curious minds who share our dedication to uncovering the universe's greatest mysteries. Together, we're not just watching videos about space, we're exploring the universe, one fascinating discovery at a time, pushing the boundaries of our understanding and imagination. Let's begin our cosmic journey where it feels most familiar, right in our celestial neighborhood with the rocky planets. These fascinating worlds, Mercury, Venus, Earth, and Mars, represent nature's most impressive construction projects. Imagine a cosmic architect working with essentially the same building materials, rocks, metals, and gases, yet managing to create four dramatically different worlds, each with its own unique personality and secrets. Let's start with Mercury, our solar system's innermost planet. This remarkable world takes the concept of extremes to an entirely new level. Sitting so close to the sun, its surface temperatures soar to a staggering 800 degrees Fahrenheit during the day, hot enough to melt lead. But here's the truly mind-bending part. At night, those same areas plunge to negative 290 degrees Fahrenheit. This dramatic temperature swing creates an extraordinary phenomenon where certain metals can actually flow like water across the planet's surface, creating metallic rivers unlike anything we've ever seen on Earth. Moving outward, we encounter Venus, often called Earth's evil twin, and for good reason. Despite being almost identical to Earth in size and mass, Venus has evolved into a world that seems designed to challenge our very definition of hellish. Imagine standing on its surface. If you could survive, you'd be crushed by an atmosphere 90 times heavier than Earth's, while acid rain containing sulfuric acid falls from yellow-tinged toxic skies. The surface temperature, a scorching 900 degrees Fahrenheit, is hot enough to melt lead, making Venus the hottest planet in our solar system, even hotter than Mercury. Then we have our own world, Earth, a cosmic oasis that represents a perfect balance of elements. It's the only planet we know of where rock and water coexist in all three states, solid, liquid, and gas, creating the perfect conditions for life as we know it. Our planet's unique combination of moderate temperatures, liquid water, and protective atmosphere has created something truly extraordinary in our cosmic neighborhood, a living world teeming with diversity. Finally, we arrive at Mars, the red planet that continues to capture our imagination. Today, Mars appears as a frozen desert, its surface carved by ancient river valleys and massive canyons. But hidden beneath this current harsh exterior lies evidence of a fascinating past, a time when Mars might have looked remarkably similar to Earth, with flowing rivers, lakes, and possibly even entire oceans. The traces of this watery history are preserved in the planet's geology, telling a story of a world that underwent dramatic climate change and lost most of its atmosphere to space. Now, I want you to pause for a moment and let your imagination run wild. If you had the opportunity to walk on any of these rocky worlds besides Earth, which one would you choose? Would you brave the metallic rivers of Mercury, challenge the extreme pressures of Venus, or explore the ancient riverbeds of Mars? Each choice offers a unique adventure, a chance to experience firsthand the incredible diversity of our solar system's rocky pioneers. Think about what draws you to your choice. Is it the extreme conditions of Mercury that intrigue you? The mysterious, hostile environment of Venus, or perhaps the potential for discovering signs of ancient life on Mars? Take a moment to consider not just the destination, but what your choice says about humanity's endless curiosity about the unknown. As we venture beyond the asteroid belt into the outer solar system, we enter a realm where the laws of nature seem to have created worlds that defy our earthly expectations. Welcome to the domain of the gas giants, Jupiter, Saturn, Uranus, and Neptune, where everything exists on a scale so massive it challenges our comprehension. These cosmic behemoths are so different from their rocky inner system siblings that they might as well have been born in another solar system entirely. Think of these worlds as stars that never quite made it. While they didn't gather enough mass to ignite nuclear fusion in their cores, they still grew to become something extraordinary. Jupiter alone is so massive that you could fit over 1,300 Earths inside it. But what's truly fascinating isn't just their size, it's what's happening within these gigantic worlds. Let's dive beneath their cloudy exteriors, starting with something that sounds like it belongs in science fiction: metallic hydrogen oceans. Deep within Jupiter and Saturn, the pressure is so intense, millions of times stronger than Earth's atmospheric pressure, that it actually transforms hydrogen into a metallic liquid that conducts electricity like copper wire. These exotic oceans are so deep that you could stack several Earths end to end and still not reach the bottom. This metallic hydrogen layer is crucial. It's responsible for generating the powerful magnetic fields that make Earth's magnetic field look like a tiny refrigerator magnet in comparison. The storms on these giants redefine our understanding of weather. Jupiter's Great Red Spot, a storm that has been raging for at least 400 years, could swallow Earth whole, twice over, and that's just one storm on one planet. Saturn has periodic superstorms that wrap around its entire circumference, while Neptune hosts the fastest winds in the solar system, with speeds reaching up to 1,200 miles per hour. That's faster than the speed of sound on Earth. Then there are the ring systems, with Saturn's being the most spectacular. While all four gas giants have rings, Saturn's main ring system would stretch from Earth to the Moon if laid out flat. Yet they're mostly no thicker than the height of a house. These rings are composed of countless pieces of ice and rock, ranging from microscopic dust to chunks the size of buildings, all dancing in an orbital ballet that's been ongoing for billions of years. But perhaps the most mind-bending aspect of these worlds is their internal structure. Unlike the rocky planets, which have clear, solid surfaces, these giants transition gradually from gas to liquid to something that might be solid at their cores, but we're not entirely sure. Imagine trying to determine where the atmosphere ends and the surface begins, on a world where the gases just keep getting denser until they become liquid without any clear boundary. Now here's a thought experiment that astronomers actually take very seriously. What if Jupiter was where Mars is now? The implications would be staggering. Its immense gravitational pull would completely reshape the inner solar system. Earth's orbit would likely become unstable, our seasons would be chaos, and our moon might even be torn away from us. The asteroid belt would probably never have formed, and the entire evolution of our solar system would have taken a dramatically different path. This isn't just a fanciful scenario. It relates to one of the most fascinating theories in planetary science. The idea that Jupiter may have actually migrated through the early solar system, its massive gravity sculpting the planetary system we see today. It's a reminder that the serene view we have of our cosmic neighborhood masks a violent and dynamic history that continues to influence our existence. Now we arrive at perhaps the most fascinating part of our cosmic story, the great divide that splits our solar system into two distinct regions. This remarkable separation between rocky and gaseous worlds isn't random chance. It's actually a cosmic fingerprint left behind by the very process that created our solar system, and it tells us an incredible story about our origins. Picture our early solar system as a massive disk of gas and dust swirling around our newly formed sun. Within this disk, there existed an invisible boundary that astronomers call the frost line, a cosmic Mason-Dixon line that would ultimately determine the fate of every planet in our solar system. This frost line marked a critical temperature boundary, much like the line where snow starts to appear as you drive up a mountain. Inside this frost line, closer to the sun, temperatures soared so high that only the hardiest materials could survive. Light elements like hydrogen and helium, along with compounds like water, methane, and ammonia, were literally boiled away into space. What remained were only the toughest materials, metals, rocks, and minerals that could withstand the intense heat. These materials would eventually come together to form the compact, dense worlds we now know as the rocky planets. But beyond the frost line, in the outer solar system, an entirely different story was unfolding. Here in the cold reaches of space, those same light elements that were driven away from the inner solar system could condense and freeze. This created a region rich in ice and light gases, providing abundant material for planet formation. The worlds that formed here had access to vastly more building material, allowing them to grow into the enormous gas giants we see today. But here's where the story takes an unexpected turn, one that has revolutionized our understanding of solar system formation. Recent discoveries have led scientists to propose what they call the Grand Tack hypothesis, and it's nothing short of mind-blowing. According to this theory, Jupiter, our solar system's largest planet, didn't always stay put where we find it today. Instead, it embarked on an epic journey that nearly spelled disaster for the entire inner solar system. The theory suggests that shortly after its formation, Jupiter began migrating inward toward the Sun, drawn by the gravitational effects of the gas disk that still remained. Like a cosmic bulldozer, it pushed and scattered everything in its path. It may have approached as close as where Mars orbits today, and its massive gravitational influence would have wreaked havoc on the forming planets in the inner solar system. But then, something remarkable happened. Saturn, growing behind Jupiter, caught up to its bigger sibling. The combined gravitational dance between these two giants actually reversed Jupiter's direction, sending it retreating back to its current position. This cosmic choreography may explain one of the most puzzling aspects of our solar system, why Mars is so surprisingly small. Think about it. Mars is just a tenth of Earth's mass, which has always puzzled scientists. The Grand Tack hypothesis suggests that Jupiter's journey through the inner solar system swept away most of the building materials that would have been available for Mars's formation. essentially stunting its growth. It's as if Mars was the cosmic runt of the litter, its small size a permanent reminder of Jupiter's ancient migration. This revelation completely changes our understanding of solar system formation. Rather than seeing our planetary system as the result of a calm, orderly process, we now understand it as the product of a much more dynamic and chaotic series of events. Our very existence might be the result of this perfect cosmic choreography. If Jupiter had stayed in the inner solar system just a little longer, Earth might never have formed in the way it did. You might wonder why we spend so much time studying these distant worlds in our solar system. The truth is, understanding the dramatic differences between our planetary neighbors does far more than simply satisfy our scientific curiosity. It opens doors to some of the most important questions humanity has ever asked. Think about this. Every time we uncover a new secret about Venus's runaway greenhouse effect, we learn something crucial about Earth's climate future. When we study how Mars lost its magnetic field and subsequently its atmosphere, we're actually reading a cautionary tale about planetary protection. These cosmic case studies are like mirrors reflecting possible futures for our own world, helping us better understand and protect our planetary home, but perhaps most excitingly, our growing understanding of planetary diversity is revolutionizing our search for life beyond Earth. As we discover thousands of planets orbiting other stars, the lessons learned from our own solar system become invaluable. We now know that just because a planet is Earth-sized doesn't mean it's Earth-like. Just ask Venus, our so-called twin that turned out to be radically different. This knowledge helps us better identify which distant worlds might truly be capable of harboring life. The implications of this research extend even further into humanity's future. As we prepare to become a space-faring civilization, understanding the extreme environments of other planets becomes crucial for survival. The harsh radiation on Mars's surface, the crushing pressures of Venus's atmosphere, the intense magnetic fields of Jupiter. These aren't just scientific curiosities anymore. They're real challenges that our engineers and astronauts will need to overcome as we expand our presence in the solar system. Moreover, studying these worlds helps us appreciate just how special our own planet is. Earth exists in a delicate balance. Not too hot like Mercury, not too cold like Mars, with just the right combination of elements and conditions to support the incredible diversity of life we see around us. This understanding doesn't just inform our search for other habitable worlds, it reinforces the importance of preserving the precious planetary oasis we already have. Consider this. Every time we send a rover to Mars or a probe to Venus, we're not just collecting scientific data, we're writing the first chapters of humanity's greatest adventure. The knowledge we gain from studying our neighboring worlds directly influences the development of technologies we'll need for future space exploration. From designing spacesuits that can withstand extreme environments to developing life support systems that can function on other worlds, our understanding of planetary diversity is quite literally paving the way to the stars. And perhaps most profoundly, this research helps us understand our own cosmic origin story. By studying how different planets formed and evolved, we're piecing together the chain of events that led to our very existence. It's a humbling reminder that we're part of something much bigger than ourselves, a vast cosmic web where each planet, including our Earth, plays its own unique role in the ongoing story of our universe. As we conclude our journey through the cosmic neighborhood we call home, we're left with a profound appreciation for the remarkable diversity that surrounds us. Our solar system isn't just a collection of worlds randomly scattered around the sun. It's an intricate tapestry where each planet contributes its own unique thread to the grand cosmic story of our existence. From Mercury's metal-melting days and frigid nights to Venus's acid-laden skies, from Mars's dusty red deserts to Jupiter's endless storms, each world we've explored today tells us something extraordinary about the nature of our cosmic home. But perhaps the most remarkable revelation is how all these contrasts, these dramatic differences between worlds, might actually be the very reason we're here to contemplate them. Think about it. If our solar system had formed differently, if Jupiter hadn't performed its cosmic dance that possibly shaped the inner planets, if Earth hadn't ended up in just the right place with just the right amount of materials, we might not be here at all. The same forces that created worlds as different as Mercury and Saturn also created the perfect conditions for life on Earth. It's a humbling thought that makes our planet's position in this cosmic ballet seem all the more precious. The story of our solar system is, in many ways, our own origin story. When we look up at these planets in the night sky, we're not just seeing distant worlds, we're seeing different chapters of the same book that gave rise to our existence. Each planet, with its unique characteristics and peculiarities, helps us understand not only where we came from, but also where we might be going. And speaking of where we're going, this is just the beginning of our cosmic exploration. While today we've focused on the planets, our solar system holds even more surprises in store. Next week, we'll venture into perhaps an even more fascinating realm, the mysterious moons that orbit these planets. From Europa's ice-covered oceans to Titan's methane lakes, from Io's volcanic hellscape to our own moon's hidden secrets, we'll discover worlds that make our solar system even stranger and more wonderful than you might have imagined. This is why I invite you to continue this journey of discovery with us. By subscribing to Exploring the Universe, you're not just joining a channel, you're becoming part of a community of cosmic explorers, united by our shared curiosity about the universe and our place within it. Together, we'll continue to uncover the mysteries that surround us, one celestial body at a time. Remember, every time you look up at the night sky, you're seeing more than just points of light. You're witnessing a family of worlds, each with its own unique character, each playing its part in an ongoing cosmic symphony that began billions of years ago and continues to this day. It's a story that belongs to all of us, a story that we're still working to understand and one that never ceases to fill us with wonder. Thank you for joining me on this cosmic journey today. Until next time, keep looking up, keep wondering, and keep exploring the universe with us. The mysteries of our cosmic backyard are waiting to be discovered, and I can't wait to share more of them with you.